So chapter 5 is dealing with financial mathematics, and this is one of the key focuses of finite math. It's also one of the things that many people find the most relevant to them. There are things in finite math that we use in the fields, in things like business and economics, in the social sciences, in the natural sciences, and computer programming and other things. Chapter 5, the mathematics of finance, are things that we use in everyday life. And so this is that sort of practical thing that people sometimes accuse mathematics of avoiding, so I hope you find it useful. I'm going to break this up into a few videos because I'm going to spend a little bit of time on all of the things. I'm also going to go and take a look at some examples on my math lab to sort of work through some of these problems. So in this first video, we're going to talk specifically about simple interest. And we'll talk in the next video about compound interest. Simple interest isn't used a lot. If you go to a bank to get a loan, if you buy a car, if you buy a house and get a mortgage, you are not getting a loan with simple interest. On the other hand, if you ask a friend for a loan and say, hey, I'll pay it back plus 5% interest, that's a simple interest loan. And the simple interest loan formula is this. The amount of interest that you would either pay on a loan or that you would get if you were giving someone a loan on P dollars at an interest rate R per year for T years is this. Capital I equals capital P times R times T. Again, I here is the interest that you either earn if it's an investment or that you will pay if it's a loan. P is your principal. The principal is how much you have borrowed if it's a loan, or how much you have deposited if it's like a savings account, or how much you've invested if it's some other sort of investment account. R is the interest rate, and we always write the interest rate as a decimal here. So if the interest rate were 5% interest, we would write 5% interest as 0.05. If it were 20% interest, we would write it as 0.2 or 0.20. If it were 1% interest, we'd write it as 0.01. So remember from other math classes how to convert from a percentage to a decimal and back again. Not doing that correctly is a common mistake. The other most common mistake that people make is with T here. T is in years. So if it's 2 years, T would be 2. If it's 10 years, T would be 10. That makes sense. Sometimes your interest, the time though, isn't going to be for multiple years. It's going to be for months. If it's months, it is fractions of a year. 7 months is 7/12 of a year. 3 months is 3/12 or 1/4 of a year. 6 months is 6/12 or 1/2 of a year. So if I had 8 months of a loan, then T for 8 months would equal 8 out of 12, which we could simplify by dividing both the numerator and the denominator by 4 to be 2 out of 3. So remember for T, when you're dealing with months, you need to put the number of months over 12. If it were 14 months, that would be 1 year and 2 months. In a case like that, T would be what? It would be 14 over 12, which again, we could simplify as 7 over 6. So remember, T is always in years. So if your time period is not in years in the problem, you have to convert it. So 8 months, 8/12 of a year. 10 months, 10/12 of a year. 1 month, 1/12 of a year. Here's an example. To furnish a new apartment, Maggie Chan borrowed $4,000 at 3% interest from her parents for 9 months. How much interest will she pay? So again, we have our formula here. Capital I, that's the amount of interest she'll pay, equals the principal times the interest rate times the time period. So to figure out how much interest Maggie will pay, we take the principal, that's how much here that she borrowed, $4,000, times the interest rate. What would R be here for 3% interest? What would we write? We would write 0.03. And then time, 9 months. How would we write 9 months in terms of T, in terms of years? That would be 9/12 of a year, which we could simplify to 3/4. So when I multiply 4,000 times 0.03 times 9/12, I'm going to come up with the interest that she has to pay her parents. And when we do that, we see that she is going to pay a total of $90 in interest. Read questions carefully. Sometimes questions will ask how much interest the person has to pay. Other times they'll ask the question, how much will they have to repay altogether? And so in a case like that, we would add our interest to the original value. So Maggie pays a total of $90 in interest. That's the question asked here. But another question might be, how much will she pay altogether? That would be $4,090, because remember, she's paying back the original amount also. And that's the future value formula. At its simplest, the future value formula is the principal plus the interest rate. We usually instead use this formula on the right, because this formula means we don't have to calculate let me take that back, sorry. The future value, A, is the principal plus the amount of interest paid. The principal plus the amount of interest paid. I think I said interest rate before, and that's wrong. It's not the rate, it's how much interest altogether you pay. The shortcut way to do this, so we don't have to calculate the interest separately, is the formula on the right. The future value, which we usually use capital A for. You might sometimes see capital F, capital V for future value. In words, you might see maturity value instead also. So the future value A of P dollars, that's our principal, for T years, at the interest rate R per year, is either we can find out the interest separately and add it to principal, but usually we use this formula on the right. It is P times the quantity, 1 plus R times T. So using our example from the previous slide and Maggie's car loan. Let me go back a slide so I get all this stuff right. 4,000, 3% interest. So from that previous slide, we have a principal of $4,000. We have an interest rate of 3%, so that's going to be 0.03. And we have T for time of 9/12, which we could simplify as 3/4. You don't have to simplify it here if you don't want to, though. So how much will Maggie have to pay back altogether? That means the interest plus the principal. So we already figured out before this way. But let's pretend we hadn't figured out the interest separately first. Let's use the formula on the right by plugging this in. Our future value A is going to be $4,000 times the number 1 plus the interest rate times 9/12 or 3/4. So remember, we always use order of operations, or PEMDAS, if you remember that rather. And so that means we multiply and divide before we add, and we always do what's in parentheses first. So when we multiply 0.03 times 9/12, we get 0.0225. When we add that to 1, we get obviously 1.0225. And when we multiply 4,000 times 1.0225, we get 4,090. Remembering our dollar sign for our final answer, we see that Maggie will pay back a total of $4,090. Again, if you're figuring out the amount of interest separately, it's going to be quicker just to add that to the principal. But in many problems, you won't be figuring it out separately. It'll just be something like, and this is true for investments too. So it might be a thing like DeMarcus invested $500 into a savings account that earns 3% interest. He kept it in there for 10 years. and it's simple interest. How much will he have at the end? So rather than figure out the interest separately, we can just use this formula. And so that becomes quicker for us. This is a formula that you should put in your notes for the final exam. Let me say that again. This is a formula that you should put in the notes you're going to use for the final exam. You will have to use simple interest on the final exam for this course. We can also work backwards a little bit from that formula, and we could do this algebraically to solve it for P to find present value. And the idea of present value is if we need a certain amount, this would be like for a savings account or for an investment account. And so what present value is saying is if in 5 years' time, I need $1,000. So let's put some of that in here. In 5 years' time, I need $5,000. Or sorry, $1,000 is what I said. So that's my amount. That's my future value. In 5 years, I need $1,000. I want to know how much do I have to deposit today to get $1,000 in 5 years. I want to deposit as little as possible in order to get $1,000 in 5 years. And let's say my savings account pays more than savings accounts pay today typically. And let's say I get my interest rate is 4.5%. So that would be 0.045 as a decimal. So I want in 5 years' time $1,000. I want to know how much do I have to put in the bank to put it in and forget about it. I'm not going to add anything to it. I'm just putting it in and forgetting about it. If I can get 4.5% interest, how much do I have to put in today to have $1,000 in 5 years' time? That's when we use this formula. This is the formula for the present value, P, of some future amount. In other words, what is the principal I have to deposit today to have money in the future? So when we plug this in, we're going to get that P equals $1,000, because that's how much I want in 5 years' time, over the number 1 plus 0.045, that's the interest rate we're getting in this bank, times 5 for 5 years' time. Remember that the fraction bar is both division, but it also acts as a grouping symbol. So we're going to do everything in the denominator first. We first multiply 0.045 times 5, then we're going to add 1 to our answer. And so when we do that, we have 1,000 divided by 1.225. And when I do this on the calculator, I get this as my answer. It's approximately 816.3265. I'm always going to round to the nearest cent. And so I'm going to say that I need to deposit $816.33 today. If I had a savings account that paid 4.5% interest, simple interest, and I deposited $816.33 today, then in 5 years' time, I would have $1,000. We could check this by plugging this value into our future value formula. We could replace P here with $816.33, and we would find that A is right around $1,000. Because of rounding, it might be a penny more, or hopefully it won't be a penny less. We like it to be more, not less. So that's what you need to know for simple interest. And the idea of simple interest is that the interest gets paid or charged just once. That is not used a lot in the real world. The real world uses compound interest more, which we'll talk about in the next video. If you want to watch the rest of this video, I'm going to work some examples from MyMathLab. So I want to start with a question that is a little harder than what we've done so far. This is an economics question. For a 2-year bond of $2,200 at a simple interest rate of 9% per year, we're asked to find two things. find the semi-annual interest payment and the total interest earned over the life of the bond. So a bond is one particular type of investment. And what a bond basically is it is an investment in a company's debt. By buying a bond, what you're basically doing is loaning a company money. And the company says at the end of a certain time period, which is the maturity period, you are going to get your money back and you are going to get interest either along the way or you are going to get it all at the end. Here it says our interest payment is semi-annual. What does semi-annual mean? It means twice a year. Semi-annual is 2 times a year. So if I get 9% interest for a year, how much interest would I get for 6 months, for half a year? Hopefully you see that you would get half of 9%, which is 4.5%. Do you see that? Because it's 9% for a year, for 6 months, which is half a year, it would be half of 9%, which is 4.5%. So to find that payment, I just multiply my bond's face value, which is what we'll say here of $2,200, times that 6-month interest rate. So 0.045 for 4.5%. And so my semi-annual interest rate that I will earn every 6 months on this bond is $99. And then the total interest. Well, the bond is 2 years, and I get paid $99 twice a year. So I'm going to have $99, and I'm going to get a total of 4 payments. One after 6 months, one after 12 months, one after 18 months, and one after 24 months. So 99 times 4 is my total interest earned for the bond will be $396. So I did this using common sense, but we could also do this using our interest formula. So remember, our simple interest formula is the interest we pay or that we earn is the principal times rate times time. And in the first part of our problem here, our principal is the face value of the bond. It's $2,200. Our interest rate, R, is 0.09, and our time, T, is 6 months, half a year, 6 out of 12, or 1/2. And so when I multiply 2,200 times 0.09 times 0.5, I get what you see on your screen here, $99. For my total interest on the bond, my time then, instead of being half a year, is for 2 years' time. And so I take 2,200 times 0.09 times 2, and if you do that on your calculator, you should get $396. So for some simple interest problems, you can either use the formula, or in some cases you can just think about how you would find a certain percentage and then keep in mind about how long the time is. Here's a problem that's more straightforward. We want to find the simple interest. So we have our principal, we have our rate, and we have our time in months. And so what we're going to do is just on our calculator, we're going to do this. We're going to do $8,000, that's our principal, times our interest rate, 4%, 0.04, and then 6 months is 1/2 or 6/12 of a year. On many calculators, you could enter a fraction like I did right here by putting it in parentheses. Remember, all fractions are division problems. 6/12 is 6 divided by 12. I like to put them in parentheses even when I don't technically have to, because if I'm multiplying or dividing, if I'm multiplying, I don't usually have to do it. In other cases, I do. I just like to do it whenever I can. And if you have at least a scientific calculator, and you need a scientific calculator for this class, if you have at least a scientific calculator, you should have parentheses keys on it. And so when I do that, I get 160. And so my answer here for simple interest should be $160 unless I have a typo. And this is something we can always check just to sort of make sure of. If I put something like 1600, I should recognize that's way too much. If I got an answer like $16, that seems like it's way too little. So do some estimation in your head as well. That can be beneficial. On this question, we want to find future value. And so I want to remind you that our future value formula is the future value A is the principal times the quantity 1 plus the interest rate times t in years. And so here, this is for a loan I've taken. I've taken a 7.4% simple interest loan for 10 months. How do I know this is simple interest? I know it's simple interest because the word compound or compounded isn't in the problem at all. So I'm going to find A. So to find A, I just plug in my values. P is 11683. So it's going to be A is 11683 times 1 plus interest rate 7.4. That would be 0.074 times here 10 months. That's going to be 10 out of 12. You could do 5 out of 6. It's not going to make a difference. Particularly if you're using the calculator. If we were doing this by hand, we would want to simplify those fractions as much as possible. Usually it makes it for easier calculations. But here we don't have to. How you enter this in your calculator is going to vary depending on your calculator. If you have a TI 83 or 84, you can enter it just like it looks here because your calculator handles order of operations really well. Other calculators don't handle order of operations so well. So you have to know what you're doing. You have to remember that you do multiplication and division first. So step 1 here is to do this, would be to do this. First, we multiply 0.074 times 10 over 12. Then, step 2, I add 1 to that answer. Now, I've done everything I can do inside my parentheses. Then step 3, I multiply that answer by 11,683. But on the TI 83 or 84, I can actually just type this in as it looks on that screen roughly, and it will take care of order of operations for me. Again, I like to put fractions in parentheses. I recommend you do that too, personally. And so my answer is $12,403.45. We usually are just going to round this to the nearest cent, but we should actually read the problem. People in my math lab, it will tell you sometimes it will tell you to round to the nearest cent. Sometimes it will tell you to round to the nearest dollar. If you don't round it correctly, you're going to get it wrong. And here it says we're going to round it to the nearest cent. So I'm going to make this stay on top here. So $12,403.45. When we deal with numbers bigger than 9,999, it's usually a good thing to put that comma in there. Notice it has it in there in our problem. So following that model is always a good idea. Again, here we're rounding to the nearest cent because that's what it tells us to do. And we got it right. So that's finding future value. And then finally, we're going to find present value. And so our present value formula comes from our future value formula. We're just solving this for P. We're getting P by itself. So the present value formula is that for present value, in other words, for the principal, it's going to be the future value divided by the quantity 1 plus the interest rate times the time. So notice, find the present value of the given future amount. When you see future amount, that means A when you're using the formula. So my present value is going to be $40,000 divided by 1 plus interest rate 7%, so 0.07. Remember, 0.7 would be 70%. And then 22 months, that's going to be 22 over 12. 22 over 12. I'm going to draw this fraction bar the rest of the way. So again, the TI will do this all for me in one step. If I weren't using the TI, if I'm using some other calculator, you could try it first, right? Because this is just practice. Try it and see if you get the right answer or not. Some calculators, other calculators also handle order of operations well, and some don't. So what I would do here is first I would multiply 0.07 times 22 divided by 12. Then I would add 1 to that answer. Then I would take 40,000 and divide it by that answer. So I would type in 40,000 and then the division sign and then, or the division key, and then whatever I got down here. But on the TI-84, we can do this pretty easily. So I just have 40,000 in my numerator, so I'm just going to leave it like that. If I had something more complicated in my numerator, I'd put it in parentheses. Divided by, and then I want to make sure my denominator is in parentheses. So I divide it by the entire quantity. Otherwise, it's not going to work. 1 plus 0.07 times the quantity 22 divided by 12. Then notice I have two closing parentheses. My parentheses always have to match. And so I get 35,450.51699. And here, notice, I'm being asked to round to the nearest dollar. This is a common mistake that people get wrong when you're doing stuff in MyMathLab. You have to follow those directions. So if it's not rounded to the nearest dollar, it's going to be incorrect. So this to the nearest dollar would be $35,451. And what this is saying is this is how much, so pretend this were an investment, like this were a savings account. If in 22 months' time I needed $40,000 and I was getting 7% simple interest, which by the way would be an awesome interest rate if you could get that, I would have to deposit $35,451 today to get to $40,000 in 22 months' time. So those are some examples. I want to do one more that we didn't talk about though before. Come to think of it, I want to talk about discount rate. So we have here a 6-month $9,000 treasury bill, or T-bill, that's the abbreviation for it, has a discount rate of 5.958%. It was sold back in 2009. We want to find the price of that treasury bill or T-bill and the actual interest rate that was paid by the treasury. And the thing about discount rate is that it's not the same as this. So the price of the treasury bill is going to be $9,000 minus the discount. And the discount is just another way of saying simple interest formula. And so, in other words, we're going back to this basic formula here. PI equals PRT. Here we're talking about, instead of interest, we're talking about what's called the discount. But it's the same thing. So the discount is principal times rate times time. The principal is the face value of the treasury bill. So it's $9,000. The interest rate is what you get here. So that's going to be 0.05958. And then we're going to multiply that by 6/12 or 1/2. Because it's for 6 months' time. You're multiplying all of these together. When I multiply all those together, I get $268.11. And so the price of the T-bill is going to be the face value 9,000 minus the discount that I just calculated. So it's going to be 9,000 minus $268.11, which I'm putting on the calculator just off screen right now. And that works out to be $8,731.89. I want to round to the nearest dollar. That's what it tells me to do here. So that's going to be $8,732. So 8,732. And then the next part, we need to find what is the actual interest rate that the Treasury paid. So it says they're paying 5.958%. That's the face discount rate. The actual rate is not going to be the same. The rate varies depending on how much the Treasury bill is actually sold for, how much someone actually pays for it. So to do this, we're actually solving for R in this formula. The D here is the discount that we figured in the previous problem. So from the previous problem, we see that D, the discount, is $268.11. And remember, this is another word, this is what we call interest when we're talking about a bond of some sort. So I'm going to get $268.11 equals principal. The principal here is our answer for part A. It's what we actually paid, what the buyer actually paid for the T-bill. So $8,732, and we're going to use the value we put. Since it says to round, we're going to round it. I don't know what R is, but T is still 6 months. It's still 6/12. And these are all multiplied together on the right. So I have $268.11 is 8,732 times 6/12 or times 1/2. And so 1/2 of 8,732 is 4,366. So I have 4,366 R. So now remember from algebra, to get R by itself, we divide both sides of the equation by the coefficient of R. So I'm going to divide both sides by 4366. So I have 268.11 divided by 4,366. And so what I get when I do that, so again, on the right-hand side, 4,306 cancels, I just have R. And on the left-hand side, I get 0.061408 and a bit more. The problem says I want to round this to the nearest tenth. So this, for interest, is going to be 6.1408% interest, which rounded to the nearest tenth is going to be 6.1%. Assuming all my calculations were right there on the calculator. So 6.1%, awesome. One thing I want to remind you is that if you're using MyMathLab, and I know if you're taking this class with me from ICCOC, you are. If you're taking it not in the summer or it's not an online only class, you're not. I use this video for those classes too. But if you are taking it using MyMathLab, remember that for question help, view an example. So if you ever get to a problem that you might struggle with, you're not quite sure what's going on with it, walk through the example. It will do a very similar problem. It will explain it. Follow along with it. Do it if you need to. Do the problem. Do it on paper if you need to as you follow along. Similarly, the other thing that's also often there is Help Me Solve This. That would actually walk you through this problem step by step. And then we give you a similar problem to do for credit. Remember too, there's also a calculator built into MyMathLab, but it's often going to be easier for you to use your calculator because the MyMathLab calculator is usually pretty simple unless it's a graphing problem. The type of calculator just depends on what the problem is. So I recommend using your own. And certainly if you're going to take another math class, especially if you're at Iowa Lakes, I strongly recommend getting a TI 83 or 84 because it is what is used in all classes beyond math for liberal arts at Iowa Lakes specifically. And they're often used at other colleges too. Check with math teachers at your college to see what they recommend. So I hope that helps you with simple interest and discount. Simple interest is more important for you to know right now than the discount rates for treasury bills. But I would be awesome if you could also do discount rates for treasury bills. That's also part of this chapter. But specifically what I want you to be able to find is I want you to be able to find the interest that you paid or that you earned from either a loan or investment. I want you to be able to find the future value. And remember, future value, A, that's how much altogether you would repay or how much altogether you would earn. And then I want you to be able to find present value given future value. In other words, how much do I need to deposit today or invest today to get to a future value some point in the future? I hope this helps. If you have any questions, please let me know.